Hey, welcome. Today, we're going to pull back the curtain on something you see all the time, but maybe don't think about. What's actually inside a blood bag? We're talking about the science that makes modern transfusions even possible. It's pretty cool, so let's get into it.
I mean, have you ever really stopped to think about that? How can living tissue, literally blood, stay fresh and ready to save a life for weeks on end? It seems impossible. But it's not magic. It's this incredible, carefully designed chemical cocktail. And yeah, it can push that shelf life to 35 days, sometimes even more. We're going to break down exactly how.
All right, so here's the game plan for this little deep dive. First, we'll tackle the biggest problem we're up against. Then, we'll meet the chemical all-stars that solve it. We're going to dissect the most common solution piece by piece. And stick around, because at the end, I've got a super simple cheat code to help you remember all of this.
Okay, let's jump right into section 1. We've got to start with the fundamental challenge. The moment blood leaves the human body, a clock starts ticking. A very, very fast clock. And that blood has one mission in mind: to clot.
Right, clotting. Inside your body, that's an amazing, life-saving feature, right? You get a cut, it clots, you stop bleeding, but once it's in a blood bag, clotting is the absolute enemy. It turns life-saving blood into something totally unusable. So, job number 1 is to stop that process dead in its tracks.
And this is our hero, the anticoagulant. It's a simple name for a substance with a massive job: prevent blood from clotting. Period. It is absolutely essential for every single step of the process, from the needle going in to storage all the way to the transfusion itself.
So, not all anticoagulants are the same. You wouldn't use a hammer to fix a watch, right? It's the same idea here. Different situations call for different chemical tools. So let's meet the all-star lineup you're going to see in any blood bank or lab.
This chart really lays it out perfectly. You can see right away that CPDA1 and ACD are the big players for storage. And notice how they work. They both go after calcium. We'll talk more about that. But look at the key difference. Storage time: 35 days versus 21. That's a massive deal. Then you've got EDTA and heparin. Think of them as specialists. They're crucial for running tests, but they are not for long-term storage.
So let's really focus on this head-to-head battle. ACD, you can think of it as the old, reliable workhorse. It did the job, it was effective, and it gave us 21 days. But then CPDA1 came along, and it's the undisputed modern gold standard. Why? Because it pushes that shelf life all the way to 35 days. That's 2 extra weeks. That's a total game changer for managing a hospital's blood supply. Okay, so what is the secret sauce in CPDA1? What makes it so special? Let's pop the hood, so to speak, on a blood bag and deconstruct this solution. We're going to see how every single ingredient plays its own vital role.
It all boils down to these 4 key ingredients. You've got citrate, phosphate, dextrose, and adenine. And you really have to think of them like a highly specialized team. Each one has a very specific job to do to keep those red blood cells alive and well.
All right, first up, we have citrate. I love this one. The best way to think of it is as the calcium thief. Its job is to chelate, which is just a fancy word for grab onto, all the free-floating calcium ions in the blood. And here's the thing. Without calcium, the entire clotting cascade, that whole chain reaction, can't even get started. It's our first and most important line of defense. Next on the team is phosphate, our pH buffer. So as red blood cells live and use energy, they create acidic waste, which isn't good. Phosphate acts like a sponge for that acid. It just soaks it right up, keeping the pH of the blood nice and stable. This makes the whole environment way healthier for the cells to survive in for a long time. Then, of course, you need food. That's where dextrose comes in. This is the RBC fuel. It's a simple sugar, and it's basically the only thing these red blood cells have to eat while they're in storage. You know, just like us, cells need energy to survive, and dextrose is their packed lunch for that whole 35-day trip. And finally, the real MVP, the special ingredient, adenine. This is the ATP helper. Now, if dextrose is the fuel, adenine helps the red blood cells actually use that fuel to regenerate ATP, which is their core energy molecule. This is the secret weapon. Adenine is the A in CPDA1, and it's what boosts their survival and pushes that shelf life from 21 days all the way to 35. So you take all those pieces, the calcium thief, the pH buffer, the fuel, and the ATP helper, and you put them all together, what do you get? You get the undisputed champion of blood storage, CPDA1. Let's just quickly recap why it's the gold standard.
Really, it all comes down to this one powerful number: 35 days. 5 full weeks. That extended shelf life is absolutely critical. It gives hospitals the flexibility they need, it dramatically reduces waste, and most importantly, it makes sure a stable blood supply is ready to go whenever a patient needs it.
And the most important thing to remember is that it's not just about a longer shelf life on a calendar. It means the red blood cells themselves are healthier. They survive better after they're transfused into the patient. And that means the patient is getting a better, more effective, more life-saving product. That's what it's all about.
And this just shows you how precise the science is here. The ratio has to be perfect. It's roughly 1 part anticoagulant for every 10 parts of blood. So, for example, in a standard bag, you're looking at about 14 milliliters of this solution for every 100 milliliters of collected blood. It's a perfect chemical balancing act.
All right, that was a lot of info, I know. So now, let's make sure it all sticks. I'm going to give you a really simple tool, a little cheat code to lock in all this knowledge. This is especially going to help if you're studying for an exam or just want to remember the key players.
You ready? Here it is. Your new favorite mnemonic. Cheddar prevents daily clotting. Yeah, it's a little silly, I'll give you that. But trust me, it's an incredibly powerful way to remember all the most important anticoagulants and the key ingredients we just talked about.
Let's break it down so you see how it works. The cheddar part covers the big 3 anticoagulants. C for citrate, H for heparin, and E for EDTA. Got it? C-H-E. Then, prevents gives you the key ingredients of our champion solution, CPDA1. D for dextrose, the fuel. A for adenine, the ATP helper. And P for phosphate, the pH balance. See? Cheddar prevents daily clotting. It covers all our bases perfectly.
So, when it's all said and done, what's the big takeaway? It's this. That clear liquid you see in a blood bag, it's not just some random fluid. It's a sophisticated, high-tech life support system. These anticoagulants are truly the unsung heroes, working quietly behind the scenes to make safe, life-saving transfusions possible every single day.
That jump from 21 to 35 days was a revolution. And today, some new additive solutions can push that shelf life even further. It really makes you wonder, doesn't it? What's the next big breakthrough going to be? What's the next innovation that's going to completely change how we save lives with donated blood? It's something to think about. Thanks so much for joining me.